Hello. Can you all see the screen?
Yeah.
So all of people who have joined, can you go to www.menti.com and enter this code? So either you can go to www.menti.com or enter the code, or you can scan using the QR code. Can you all please join so that we can start the session?
I'm joined now.
Okay, so we'll start the session now. Everybody join. So we'll move to our first question. So the first question says, let you have two independent discrete random variable, that is x and y, and their CDFs are given as fx and fy. Now, you have to define, you have to find another random variable z as minimum of x comma y. Now there are four options, and you have to select one of whatever possible answers are there. You have to mark it. So there are four options regarding the CDF of minimum of x comma y. Now you have to select whatever is possible. So I will give the time for like 3 minutes. It's not so difficult. So after that, we will see the solutions. Is it okay?
सुबह तो तुम अभी आए नहीं। तुम्हारे लिए 10 लिखा हुआ था बाकी
Can you unmute yourself?
Ma'am, where to enter the answer? Ma'am?
You're not getting any options?
No, ma'am. It's just the question that is getting displayed. I joined with the code. I just went to menti.com and joined with the code that you gave.
Just hold on.
Okay. Yes, ma'am. Now it is come.
It is coming, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
So all of you done? So, or do you want more time?
Yes, ma'am, you're done.
So anybody here wants to explain what they have done? Anybody wants to explain? Okay, let's move with the solution. So, okay. The code you can see on the screen. Look at the screen. It is 20533985. It is there on the screen. You can. Yeah. So most
Madam,
of
the
people.
voice was very loud.
Sorry, voice is lagging.
No, it is okay, ma'am.
Okay, okay, sure. So most of the people have answered option 3. So nobody is there who wants to explain. Okay, let's see the
Ma'am,
question. Yeah.
we are trying to find out the minimum value. So we do not have a direct CDF for minimum. So what we are doing is we are doing 1 minus we are finding the complement of the maximum. And one borderline is equal to Z and we are excluding that. So we are doing 1 minus X greater than Z, Y greater than Z.
So it was a multiple select question. You could have selected more than one
So
option.
A and C.
A and C. Yes, that is correct. So why both the options are correct?
Because X and Y are independent variables. So joint probability
That
is equal to
yes, that is correct.
multiple. Yes, sir. Yes.
So we had to find the CDF of minimum of XY, right? So what is f z of z? It is probability of z less than equals to z. And what is z? Z is given as minimum of XY. So why we are doing minus here? Because see, if there are two random variables and if the minimum is less than z, it is not necessary that both of the numbers will be less than z. But if we write it as 1 minus probability of z greater than z, then we know that if the minimum is greater, then the other number will also be greater. So we can write it as probability x greater than z and y greater than z, right? And since they are independent, x and y are independent, so we can split into two parts. So it will be 1 minus probability x greater than z, probability y greater than z. Is it all right? Anybody has doubt in this question?
Ma'am, can you show us the options again?
Sorry.
Can you show us the options again?
Okay. Yeah.
The B option is not correct. Why is that?
Yeah. See. Why is B option not correct? So f z of z, what will you write? You will write probability z is less than equals to z, right? And what is that? Minimum of xy less than equals z, correct? I will okay, see that. So What I'm saying is we will write f z of z is probability z less than equals to z, and z is minimum of xy less than equals to z. So why can't we write it as x less than z comma y less than equals to z? Because if this is minimum of xy, so if the minimum is less than z, it may not be possible that both the numbers will be less than equals to z. It is possible that other number is greater than z, right?
Yeah, right. Okay, okay.
Right. So
Yeah.
if we do the minus 1 minus probability of min of xy greater than z, so if so what we are saying from probability min xy greater than z, we are saying that the minimum is greater than some number, right? So if the minimum is greater than some number, it means both the numbers should be greater than z, correct? Then we can write x greater than z and y greater than z. All right.
Yes, ma'am.
Yeah. We'll move to the next question now. So you have two independent random variables, and their PMF is given as fx of k, which is same as fi of k, and is taking the value 1/6 for k equals 1, 2, 3, 4, 5, 6. Otherwise, it is taking the value 0. Now we have defined another random variable set, that is x plus y, and you have to find the value of f z of 3. So I will wait for some time, then we'll discuss the solution.
The voting is not available.
The voting is not available. Okay, let me check. Can you check again?
Yeah, it's active now.
Yeah, okay. So is it done?
Yes, ma'am.
See, most people have answered option 2, but 2 people have answered 3 and 4. Can somebody would like to explain, like the people who have
Shall I?
answered 3 and 4? Yeah, sure.
Yeah, so it said z equals to x plus y and x plus y should be 3. So there are only two cases possible, either x be 1 and y be 2 or x be 2 and y be 1. So the probability of x equals to 1 is 1 by 6 into probability of y equals to 2 is 1 by 6. So 1 by 6 into 1 by 6 is 1 by 36. And
Yes.
this will be same case for 2 comma 1, that is x
Yeah.
equals to 2 and y equals to 1. So just
Yeah.
adding it, it would be 2 by 36.
Yes, correct. So this was quite easy. So I hope it is clear for everybody.
Yes, ma'am.
Okay. So it's the same thing that he has explained. So we had to find probability z equals to 3 and z is x plus y. So either x can take the value, either x will take the value 1, y2 or x2, y1. And since they are independent, we can easily write it as p of x equals x into p of y equals y for all the pairs x and y. And we just have to substitute the values and you will get your answer. Anybody has doubt in this problem?
No, ma'am.
No? Yeah, sure. So we'll move further. Yeah, so this question says you have again two independent random variables x and y. So x is geometric p and y is also geometric p, and we are taking assuming z to be x plus y. So there are a few options here, and you have to select what are options are possible for the PMF of z. I'll give you some 5 minutes, then we'll discuss the solutions.
Voting is not available.
Oh, yeah, sure. It should come now. Can you share the link to the Mentimeter? Please join the session meet.
Ma'am, I can't see the options in the voting.
Ma'am, should we go formula wise or should we perform summation?
Yeah, I just checked. You can give the final answer. It's fine. Multiple select is not available. Since, you can select the final answer here.
Ma'am, available.
Yes,
Yes.
multiple
It is?
choice is available.
Okay,
Yes, it is
then fine.
available.
Yeah, then fine.
Ma'am, I'm not getting the options. Get this page.
You're not getting the options.
Not getting the options.
Options are available. Can you try again?
Yes, ma'am, I'll try. Yeah, now it's there, ma'am. Thank you.
Yeah, sure.
Someone like to explain?
Is it done?
Yes, ma'am.
Yes, ma'am.
Okay. So most of the people have answered option 2 and 3.
The correct answers are 2 and 3 both, right?
Yes, both. Yeah. Um, so, can somebody explain who have answered for option 4? Who have marked option 4 as the answer? Or anybody else who wants to explain this problem?
Shall I, ma'am?
Yeah, sure.
Yeah, so option B and C are correct. One is direct formula, that is n minus 1 dot p square dot 1 minus p to the power n minus 2. And the way this formula was derived, that is third option, and that is it's given x plus y is equals to 10. So let's assume x equals to I and y equals to 10 minus I. So
Yes.
getting its probability, we would summation it. So it would be from range from I equals to 1 to 9.
Yeah, correct.
That's
So, yeah, one thing that you should not remember the formula, right? So you should try to like find the values like you should proceed for write the summation and then try to evaluate. So
Yeah, ma'am, but like
don't
an exam to
run on-
handle time
yeah,
option.
but it's not like you will get the same question, right? So it's okay if you remember the formula, but try to solve for manually. Yeah. So I just explain this problem.
Ma'am, for the second option, we've just assumed that I equal to 2, right?
Second option,
B,
instead of
B,
10 is
9p2.
9p square 1 minus p to the power 8.
Yeah.
Or what did we assume?
No, I mean, why did we take p square? It could be 3 and 7 or 5 and 5. I mean, this is an assumption that it is 2 plus 8, right?
No, see, I will show you the solution. So we had to find probability z equals 10, right? And z was x plus y. So this was x plus y equals 10.
Yeah.
Now, how we can write it as, we can write the summation.
Yeah.
And probability x, let's say x is taking the value I or y is taking the value 10 minus I. Right?
Correct. Yeah.
And I can only take the value from 1 to 9. I
Yeah.
cannot take the value 10, right? Because it's
Yeah.
geometric distribution.
Yeah.
Now we also know that they are independent, so we can write it separately as a product form, like probability x equals I into probability y equals to 10 minus I.
Correct.
Now x is geometric distribution. So what we can write, so what is probability x equals k when x is geometric?
It is 1 minus pi minus 1 into p.
Right? So that is
Yeah.
what we have written here. And same
Yeah.
probability y equals 10 minus I.
Oh,
Now
okay.
this p square, we can take it out.
Okay.
Correct?
Okay. Yeah. Got it, ma'am. Yeah. 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 I got confused a little bit. Yeah.
Yeah.
Thank you, ma'am.
So is the solution clear to everybody?
Yes, ma'am.
And can you explain again why we cannot take 10? Why
Yeah,
that I
see.
cannot take 10?
What is x?
It is a symmetric distribution.
Y is also a geometric distribution, right?
Yes, ma'am.
And what is the range of values that geometric random variable can take?
It can take values 1 to 9. Okay.
1 to 9. I mean, I'm asking in general.
It is up to the last time that you get a success. It is a
Yes.
Before
up to
a
that
success.
value. Yeah.
Yeah, so it can take the value from, like, it may take the value from 0, but what we have been following is like we are following it from, like, it starts from 1, right? So the range of geometric random variable, if we in general, if we ask, it is 1, 2, 3, it can go up to infinity, correct? In general, if x is a geometric random variable, the range of it will be 1, 2, 3, 4. It will go on. That is right.
Yes, ma'am. Okay.
So if I write I equals 1 to 10, what will happen?
Value of y will become 0.
Yes. So if we put I equals 1, I equals 10, then y equals 0. So, but the range of values that x and y are taking are starting from 1. So 10 is not possible. So we'll have to restrict the I from 1 to 9. It cannot go beyond that. Right?
Okay, so we can start I from 0 also.
But our convention, like, if you have seen the lecture, sir has mentioned this, like, we'll start.
Yeah, the sir took from x equal to 0 to z. That summation was there for a Poisson distribution.
No. It is not Poisson. It is a geometric distribution. If it is
Yes.
Poisson, of course, you can take it from 0. But this is a geometric random variable that is like mentioned in the problem, right? That x and y are geometric random variables. So the range of the values that will take is from 1. It will start from 1. So that is why we'll have to restrict that 9. Is it clear?
Yes, ma'am.
Yeah.
Ma'am, I have just a question?
Yeah.
The last this thing, can we generalize this formula to say z minus 1 p square into 1 minus p to z minus 2?
Yes, it can be generalized. Like, if you try to find the value, if you try to calculate for some value, you will always get the similar expression.
Thank you,
like
ma'am.
the general form. Yeah. Yes. Okay, so is this clear to everybody? This question is fine.
Yes, ma'am.
Yeah. So move to the next question. So it is a continuation from the previous question. Now you have again the same question, like x is geometric p, y is geometric p, and they are independent, and you are taking z to be x plus 5. Now you have to determine the values of p for which probability x z equals 10 is less than p z equals 9.
Geometric X, geometric Y.
Can't see the voting, ma'am.
Sorry, you can't mark the options. The options.
The voting is, yeah, there's no options coming.
Options
Just getting the
come.
question on.
We're able to see.
See, right? Yeah. Is it done?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Option 4. So who has answered option 4?
I did.
Okay. Okay, can you explain why did you mark option 4?
I think I made a mistake in the inequality. It should be.
Oh, okay.
I
Okay.
didn't
Yeah.
see the, yeah, there's a minus sign, so I should have.
Yeah, it's okay.
Yeah.
It's fine. So yeah, the correct option for this question is C. So you had to just determine, like, you had to find the value of P basically for which this inequality will satisfy. That probability Z equals 10 is less than probability Z equals 9. So from the previous part, if you see, the way we have found probability Z equals 10. Similarly, we will try to find probability Z equals to 9. So you will follow the same step, and you will get probability Z equals to 9 as 8 into P square 1 minus P to the power 7, right? And you have to like find the value of P for this inequality, that is probability Z equals 10 less than probability Z equals 9. So when you substitute the values and you solve it, you will finally get P greater than 1 by 9. Anybody has any problem in this question?
No, ma'am.
Okay.
Okay.
Okay. All right. So this is our next question. So we have two random variables that are independent, and x is given as Bernoulli 0.4 and y is Bernoulli 0.2. Now you have defined another random variable that is z equals x plus y, and you have to find the value of f z of 1. I'll wait for a few minutes, then we can discuss.
Ma'am, the options are not yet coming.
It should come. Can you check? Can you check again? It should come.
No, ma'am, it's not coming.
It's not coming for anybody. Sorry.
I'm able to see now.
Okay. Yeah. Sure. Is it done?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. Right. I can see there are many participants, but they're not answering. So we had two random variables x and y, and they were given to be Bernoulli, that is 0.4 and y 0.2. And now we have defined another random variable z to be x plus y, and we have to find the value of f z of 1. So this is quite easy. So as we can see, x is Bernoulli, so either it can take the value 0 or 1. There are not any possibilities. So either x will take the value 1 or y, because f z is 1. So that is probability z equals 1 and z is x plus y. So basically probability x plus y equals 1. Now either x can take the value 1 or y can take the value 0, or x can take the value 0 or y can take the value 1. Again, we have to use the independence condition, and using the independence condition, we'll get probability x equals 1 into probability y equals 0 plus probability x equals 0 into probability y equals 1. And from there, you can see that your x is given to be Bernoulli 0.4. So basically, your probability of success is 0.4. It means probability x equals 1 will take the value 0.4 and x equals 0 will take the value 0.6. Similarly, y equals 1 will take the probability 0.2 and 0 will take the value 0.8. So we'll just substitute those numbers here, and if you solve it, you'll get the answer 0.44. Is this clear? Anybody has any doubt in this?
No, ma'am.
No? Right. Okay. So the next question is again the continuation from the previous one. So in this case, you have to find the value if x given z equals 1 of 1. Is it done?
Yes, ma'am.
Yes, ma'am.
Not many people have answered. Okay, so we have three options here, 2, 3, and 4. Would anybody would like to explain?
Ma'am, can I do?
Yeah, sure.
Is given to find f of x given z equals to 1 of 1. So we can write it as p x equals to 1 and z equals to 1 by p of z 1. So we have found out earlier that p of z of 1 is 0.44. and p x equals to 1 and z equals to 1 is possible when 0.4 into 0.8. So 0.4 into 0.8 by 0.44 gives us 0.73.
Uh,
So
yeah, yeah, right. Yeah. Yeah, so that is a correct explanation. Yeah, so it was given to us that x is Bernoulli zero point 0.4 and y is Bernoulli zero point 0.2, and the set is x plus y, and we had to find f of x given z equals 1 of 1, and that is nothing but probability x equals 1, z equals 1 divided by probability z equals 1. So z equals 1 is possible only if y equals to 0. So this is going to be y probability of x equals 1 comma y equals 0 divided by z equals to 1 we have already found, so we can directly use that number, and that we have got to be 0.44. So this is going to be probability x equal 1 into probability y equals 1, that is zero point 0.4 into 0.8. So you will get 0.32 divided by 0.44. So you'll get 0.73. I hope this is clear to everybody.
Yes, ma'am.
Yes, ma'am.
Okay, yeah. We'll go to the next question. So the joint distribution of x and y is given to you, and the ranges are of x and y are 1, 2, 3, and so on. Again, our probability mass function is z equals x plus y, and you have to find the probability mass function of z. Okay, is this question clear to everybody?
Yes, ma'am.
Yes, ma'am.
Yeah. So should we move to the solution, or there is somebody who wants to answer?
Answer will be 3.
C. Yeah.
Third number.
Yes, that's correct. Not many people had answered.
Because the options are not coming
Options are not coming.
in the Menti.
It should have come, yeah, because some
Yeah,
people
yeah.
have already answered. Yeah.
Yes, ma'am. 3 is the answer.
Yeah, correct. So what we have to do is, so this function you must have seen in your practice assignment. So there you had to find the probability mass function of maximum of xy. But here we have we have to find the probability mass function of x plus 5. So whenever you have to find PMF, like for a function of random variable, what you should first do, you try to write the range of that function, and then just calculate the values. And if you can see the pattern, you can just mark it. So as we can see in this question, so xy are in the range of 1, 2, 3, 4, and so on. And the ranges of x plus 5 will be, it will start from 2, right? Because 1 plus 1 can, maximum it can go to 2, like minimum should be 2. So 2, 3, 4, and it will go like that. So 2, 3, 4, and so on. And if you just substitute the values there, so if you can try to plot the table, right? You can try to plot the table, and once you do it, you can see that f of z of k will come out to be 1 by 2 square. Fz of 3 will come out to be 2 by 2 cube. Fz of 4 will come out to be 3 by 2 to the power 4, and so on. So there's a pattern here. So for any k, that x plus y will take, you are getting the probability to be k minus 1 by 2 to the power k. So this is our general answer for this question. Anybody has any doubt in this problem? Any difficulty in understanding what to do?
Can we take sum over x equal to I and y equal to k minus 1?
Sum over, can you repeat?
We know the joint probability function is 1 by 2 power x plus y. So can we write z in terms of x plus y as x equal to I and y equal to k minus I and sum over it, because that is also giving the same answer?
Yeah, because that is just x plus y. Yes, you can do it.
Okay.
And can you explain this again, please?
Sorry?
Can you explain this again? I didn't get.
Your voice is not very clear. Can you?
Ma'am, that table, can you show that again?
You want to know the proof, like how to calculate this?
Yes.
Yeah. Can you explain again?
Yeah. Wait. I will stop this and I will share my screen. Okay. So your x and y, the ranges were the ranges for this was 1, 2, 3, 4, and so on, right? And our joint PMF function was defined to be x y of k to be 1 upon 2 to the power x plus y. Now we have to find one more function z that is equal to x plus y. And you have to find the probability mass function of Z. So what you can do is you can try to make a table that will be more clear. So we can write it here x, y. So x is taking the value 1, 2, 3, and so on. Y will take 1, 2, 3, and so on. So x equals 1, y equals 1. So just substitute the values here. Put x equals 1, y equals 1. So what will I get? You will get 1 upon 2 square. Correct? Now put x equals 2, y equals 1. You will get 1 upon 2 cube. Put x equals 3, y equals 1. You will get 1 upon 2, 4, and so on. Similarly, here you will get 1 upon 2 to the power 3. Here you will get 1 by 2 to the power 4. Here 1 by 2 to the power 5, and so on. So if I have to find f set of 1, right? Sorry, z is taking the value 2, right? Because x plus y, the range will be 2, 3, 4, and so on. It cannot be 1 because we are interested in the range of x plus y, and the minimum value that x is taking in 1, and same the y is taking the minimum value that y can take is 1. So if we added, the minimum we can get is 2. So 1 is not possible. So the range of for z is going to be 2. So what is f set of 2? So this is going to be probability that x plus y equals 2, right? And this is going to be probability x equals 1 and y equals 1, correct? So what is this value? This is just 1 upon 2 square. Now if we try to find f set of 3, this will be p of x plus y equals to 3. So in this case, again, you have two options. Either it can be x equals 2, y equals 1, or x equals 1, y equals 2, right? So we'll have to add those. So we'll add both these numbers. So we'll get 2 upon 2 to the power 3. Similarly, if you find f set of 4, what will you get? So here you will have 1 upon 2 to the power 4. So for 1, 3, for 2, 2, and for 3, 1, you will get 1 upon 2 to the power 4. So that will be, if you sum it all, you will get 3 upon 2 to the power 4. So you can see a pattern here, right? So for any in general k, so f set of k, you are getting k minus 1 divided by 2 to the power k. It is clear, right?
Yes, ma'am.
Yeah. So we don't have any more questions for the sessions. So if you have any general doubt, like you can ask me.
Ma'am, can you explain this from that method? If we suppose it that x plus y equal to k, and if we are supposing that y is equals to z minus x, and then we are like summing up using that summation. Can you explain from that once?
You want to explain?
Yes, ma'am. Yes, ma'am. That summation method.
You want me to explain, or you are
Yes, ma'am.
saying?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Okay. So yeah. So you're saying. Just give me a minute. Yeah. So f of xy is given to be 1 upon 2 to the power x plus y. So Z is x plus y. X plus. So what we have to find is, can you mute yourself? Yeah. So we have to find probability Z equals K, right? So this is P of x plus y equals to K. So this we can write it as sum over. So this will be probability x equals K. But let me just see, is the independence condition given there?
No, ma'am, it's not that mentioned. It's not mentioned that they are independent. That is just mentioned that a joint distribution of x and y is given like that, and that their ranges are given.
So if we take x equals I and y equals k minus I, and I will take the value from where it starts from 1 and it can go maximum till can go till infinity, right? Yeah. So
Why infinity, ma'am?
okay. Because what is the ranges of x and y? X is taking
Hi,
value
hi, it's
1
going to
to
infinity. Yes, ma'am. Yes,
right?
ma'am.
Y is
Yes.
also 1 to infinity. So the joint distribution of this is given to be this is what? This is just P of x equals x comma y equals y, right? So we can write it as in this form. So we can write it as 1 upon 2 to the power x plus y. So in this case, our x plus y is I plus k minus I, and I is varying from 1 to infinity. So 1 upon 2 to the power k, if you sum it over, will we get the same answer? So this is 1 by 2 plus 1 upon 2 square up to so on. 1 by 2, so 1 plus 1 by 2 plus 1 by 2 square, and so on. And this is what? A upon 1 minus r. This is 1 by 2. Have to do this. The lower limit should start with 2. Why is that? Sayantan. Because x equals 1 and y equals. Oh, yes. Yeah.
No, ma'am, but x equal to I, right? So it can go
But
from
k,
1 to.
yeah, so I equals 1. So k
It is
minus
correct.
1
Yeah.
is correct. So somebody had told they had solved this problem using this method.
Yes, ma'am. From this method is not coming only.
Yeah, but
I solved it
this is
from this
just
end.
yeah, like it is given to be if this is a PMF and it is a valid PMF, so it will always come out to be 1. So
Ma'am,
okay, we don't
shouldn't
have
it
to
be k minus 1 here, because
Yes, ma'am.
after
I
that,
equals to 1 to k minus 1, it should be summation.
because x plus y cannot exceed k, right?
sorry, okay, sorry. Okay, yes, x plus y cannot exceed k. Yeah, correct.
So
Yeah, I
we can
understand.
put k minus 1,
Yeah,
and
yes,
now
that is.
we will
Then
have
we'll get the answer.
2 power k. Yeah, so it will
Yeah.
be k minus 1 into 2 power k.
Yeah, now it is fine. Yeah. Yeah, thank you. So you can just take it out and yes, it will be k minus 1 by 2 to the power k.
Why we kept k minus 1 as the limit, ma'am?
Yeah, because x plus y is k, right?
Ma'am,
You're missing
why I is starting from 1? It should start from 2, na?
No, it should not start from 2 because see, here x is taking the value I, y is taking the value k minus I, right? So
Yeah.
what is the range of x? That is 1, 2, 3, and so on. What is the range of y? It is again 1, 2, 3, and so on. So here we are talking about x and y. We are not asking you. We are not writing anywhere here to, the z, right? The range for z is varying from 2,
Okay,
right?
okay.
2, 3, 4,
Okay.
and so on. But for
Okay,
x and y,
got
it's
it.
starting from 1.
Yeah, got it.
This
And it can go,
upper limit of k minus 1, I didn't get it now. This is the
yeah, so it can go maximum till k minus 1. Just put k minus 1 here. What will you get? You'll get
okay.
y
Okay.
equals k minus.
Okay, right,
Just
right.
leave it. Yeah. If it goes further, it will be 0. That is not possible.
Right.
Right. So, is there anything else you want to ask?
Ma'am, this minimum functions CDF, ma'am. Sometimes they ask, right? So actually, I mean, this time we were able to answer because it is just greater than 2. But if they are asking for the final derivation, for example, in for practice assignment, we have a question where in last tutorial 2, last question, ma'am. So they have a question where they are asking us to find a CDF of a minimum function. And because minimum does not have a CDF, we take 1 minus greater than, but that also does not give me, we don't end up with a CDF.
Just hold on. Let me check. Which tutorial it is? Week 2.
Week 2, tutorial 2.
Check.
In this question, they have directly said,
tutorial 2, question number?
Question number is, just a second. Seven now. Actually, 6 and 7 are continuous questions.
Okay, okay.
Oh, sorry, ma'am. I think it's in tutorial 1, I guess.
Tutorial 1. No, it is not in tutorial 1. You're asking about some minimum question, right?
Yes, ma'am. They've given x and y. They're saying z is min of x comma y, and they're asking us to find out f of z, capital F of z.
You check the question number. It will be easier to find.
Just a second.
It's question number 5.
Tutorial 1.
Tutorial 1, question number 5.
Yes.
Okay. So what is the problem there?
Ma'am, because minimum function does not have CDF, this one is asking for z1 less than or equal to 2. So here we are considering z1 as a function and not a variable, right?
It is z2, right? Yeah, so z2
Yeah,
is
sorry,
minimum.
Z2.
Minimum.
Yeah.
So it is a random variable, right? It's a function of
Yes.
random variable. Yeah.
So they're asking CDF of Z2.
Z2. Yeah, if z2 of 2. You have to find the value of z2 of 2.
So should we consider minimum of x comma y as less than greater than or equal to 2, or z2 as greater than or equal to 2?
Okay, wait. Yeah, so we have to find f z2 of 2. So what is this going to be? This is probability that minimum of some random variable, let's say it goes to,
It's
is
just
still
X and Y
right?
now.
It is just
It's
X
just
and
X.
Y.
Yeah, there are only two. Oh, sorry. Yes, ma'am. X1, X2, X3, X10.
It goes till X5.
Yes.
Goes till X5, and this is less than equals 2. So if I'm saying minimum of X1, X2, X5 less than equals 2, does that mean that each of the Xi's are less than 2, less than equals 2? So we have
Each of greater than equal to 2.
Minimum, we are saying minimum is less than equals 2, right? So
Yes,
whatever the minimum is, that is less than equals 2. So does that mean that each of the random variable, the value that at stake is less than equals 2?
No.
No, right?
No.
So one thing that we know that, like, what is this? This is just a random variable. So if we say probability x less than equals to x, there's one more way that we can write it as 1 minus probability x greater than x.
Yes, ma'am.
This is a discrete random variable. So same thing we will do here. So we'll write it as 1 minus probability minimum of x1 up to x5 greater than 2, right?
Yes.
But if we say minimum is less than 2, sorry, minimum is greater than 2, whatever the minimum value that is taking, it is greater than 2, right?
Yes.
So now we can say that if minimum is greater than 2, each of the number will be greater than 2.
Yes, ma'am. Okay.
Right?
Okay.
So this is what we are doing here. So we can write it as x1 greater than 2, x2 greater than 2, up to x5 greater than 2, right?
Sorry, ma'am, I am not getting why every value will be greater than 2.
See.
And in first case, why
okay,
it can't be less than?
So this is, let's say, I'm saying minimum of x1 less than 2. Let's say x1 is taking the value 2, x2 is taking the value 1, x3 is taking the value 4, x4 is taking the value, let's say 0, and x5 is taking the value, let's say 10, right? So what is the minimum of all these x1, x2, x2 to x5?
0.
This is x4, right? X4 is equals to 0. But if I write that x, so in this case, this is less than equals 2. So what all numbers, like what all random variables are satisfying that? X1 is satisfying this, x2 is satisfying, and x4 is satisfying. But does that mean that x3 and x5, they are less than 2? No, right?
But ma'am, x1 to x5 is the one set, and minimum of the function of minimum will get only one value, na?
Yeah,
we will get.
Yeah,
so
what I'm saying is you cannot write it as that all these random variable are less than equals to. We cannot write it as x1 less than 2, x2 less than 2, up to x5 less than 2. Correct?
Ma'am, we can't write all them of is
Yes.
less than 2, but we can say that minimum of that x1 to x5 is less than 2. It is right.
Yeah, this is what you have written from this f set of 2. This is what you have written. It implies from there, right?
So that's
this
why,
is just
ma'am, I am
a random
asking,
variable.
means that minimum of that x1 to x5 will give the one value, or will it give all 5 values? Means what should we consider?
Yeah, that it is possible. This is what I'm saying. It may not be possible that it will, like, each of the random variable will be less than 2, right? There are some cases where it may be greater than 2. So that is why if we write it in this way, probability x greater than less than equals x as 1 minus probability x greater than x, then if I say now that probability that minimum of x1, x2, x5 greater than 2. So
but ma'am, again it will be, suppose 0 will not greater than 2, na ma'am? Then again some conditions will fail.
No. See, so I'm saying the minimum is greater than 2. So if whatever the minimum is, let's take some different example now. This will not be valid here. So So I'm saying minimum is greater than 2. So if let's say our x2 is minimum and it is taking the value 3, x1 is taking the value let's say 4, x3, x5 is taking, x3 is taking the value 5, x4 is taking the value 6, x5 is taking the value 7. I am saying, so if this is these are the random variable set of values that these random variables are taking. So the minimum is, I am saying the minimum is greater than 2, correct? This is what I want. I want the minimum to be greater than 2. So if the minimum is greater than 2, in this case, the minimum is this is x2, right? x2 equals 3. So if the minimum is taking the, if the minimum is greater than 2, it means all of the random variables, all of the values that the random variables are taking, everything should be greater than 2. It is not possible that if the minimum is greater than 2, some of the random variable can be less than 2.
Okay, ma'am. Okay.
Right?
Means all values should satisfy.
No, like in general, we are saying.
Yeah, yeah. Means in first case, when 2, 1, 4,
From
0,
there,
10.
from
Yeah.
there we cannot write this, but from
Yeah,
there
yeah.
we can write this.
Yeah, yeah, ma'am.
Now you know how to solve this because everything is independent.
Yeah, ma'am. Thank you.
I have a doubt in activity 2.4, question number 4.
Activity 2.4, question number 4. Okay. Okay, so I will just give the hint there, so you can also check on the scores and all. So yeah, so there is a function that is defined. So x is given to be geometric p, and fx is x by 2 if x is an even number, and x is fx is x plus 1 by 2 if x is an odd number. So x is given to be geometric p, and fx is given to be x by 2 for x even, and this is x plus 1 by 2 for x odd. So you have to find the PMF of f of x, correct? Probability distribution for f of x. Yeah, f of x. So whenever you have to find the probability distribution for a function of random variable, just first check the range. So what is the range for x? What is the range for x?
1 to infinity.
1 to infinity.
Yes. So x is, since x is given to be geometric p, and we know that the range for a geometric distribution is 1, 2, 3, and so on, correct? So this is the range for x. So similarly, we should try, now we'll try to find the range for f of x. So first, the first thing that you will do is you find the range for, find range for f of x. Okay. So see, so x is taking 1, 2, 3, 4, and so on. So how is fx defined? If x is an even number, it will take x by 2. If x is an odd number, it will take x plus 1 by 2. So what is x equals 1? Is it an even number or odd number?
Odd number.
So what should f of x to be?
1. 1.
1, right? 2 is an even number, so what should be? This is again 1. For this, for 3, 2. It will come out to be 2, it again 2, then 3, 3. So this is the pattern that you will see. So if you have to find fx of 1, what you will do? If I'm saying sorry, f of x equal to 1, find this. What is this? Sorry. What is fx equals 1?
I'm not getting.
So for what values fx
One and two. Oh, that's one and two.
so for x equals 1 and for x equals 2, right? For both these x, they are taking the value 1. fx is taking the value 1. So you have to do probability x equals 1 plus probability x equals 2. Fine?
Yes.
Now what is probability x equals 1? We know that x is geometric B. What is probability x equals 1? What is mean by probability x equals 1?
That's 1 minus.
No, it means that the first success
The
in the
first
try.
success, first attempt is a success.
So what is probability x equals 1?
That's P.
It is P. What is probability x equals to?
1 minus P
1
into
minus
P.
P into P.
Yeah. So similarly, you try to find for each of the number. So as you solve it, you will get a general form and we can just see what is your answer. So always first try to see the range for the function of random variable.
One more doubt I have.
Sorry, your voice is breaking. I can't hear anything properly.
Hello. Now it's okay.
Yeah, now it is better.
Thanks for that, ma'am. One more doubt I have in lecture 2.2.
Lecture 2.2.
That lecture, in the video, sir told that one equation tool that by thinking I could get that, but mathematically how to do it.
Sorry, I can't hear you properly. It's breaking.
Ma'am, can I type?
Yeah, you can type. Yeah. Anybody else has any doubts? If you have no doubt, you can leave the session.
Ma'am, can I ask doubt?
Yeah, sure.
I have a doubt in lecture 2.11.
2.11. Okay, what is the doubt?
At about 9 minutes 40 seconds.
No, like what it is about?
Ma'am, sir has solved one question. So
Okay.
I have doubt in that question.
Can you tell me the question?
It is saying that let x1 to xn is distributed IID x. So find the distribution of the following: minimum of x1 to xn and maximum of x1 to xn.
Okay.
So ma'am, I want to know, sir is calculating CDF of these two functions.
Okay.
But as we know that for finding the distribution of discrete random variable, we use PMF. So ma'am, in that question, why sir did not use that small f? Small f means that the particular value of the random variable, probability of the.
He wanted to find the CDF of random variable. CDF
But
of the maximum of x1 to xn.
But in that question, it is not mentioned that we have to find CDF of like capital F Z less than equal to particular value or less than equal to Z, because CDF will give the distribution below the Z, right? Like less than equal to Z only for that particular range.
Let me check what is there in the lecture page. It's lecture 2.11. Okay, so he's asking about the distribution, right? Find the distribution.
Hello.
Yeah, hello.
Yes, ma'am. But why we did not calculate small fz? Because earlier we were using small f. So
So,
the difference is that,
yeah, that is for if you want, that is probability mass function. So it will give for any general
yeah.
k, any general, but any particular value that the random variables take, that will give the probability for that random variable, like
But ma'am,
that value, right?
yeah, earlier also we were using that small f, like PMF. PMF will give the
So if we are
probability for all
finding
random.
PMF,
Yeah.
if we are finding the PMF, so it will give the probability for a general I or general K that the random variable, the value random variable is taking.
Yeah.
But if I'm interested in finding the distribution, we
But
have
ma'am,
to
PMF is also distribution, no? PMF distribution
no,
of probability around the
if
all.
I just give you the general form,
Yeah.
can you find the distribution? It is not possible. If I just give you, like, if you have seen the last problem, so if I just give a general form, like uh, f of x of I is equals to 1 upon, let's say, I plus j,
Yeah.
or 1 upon let's say 1, it is 1 upon 2 square, right? So can you find the general can you find the distribution of the random variable?
So, ma'am, according to you, whenever we don't know about the event or
No,
condition,
if you are asked to find the distribution, it means you are expected to find the CDF.
but ma'am, not in all problems. Na earlier in this problem only we have
Can you
calculated
tell me
CDF.
somewhere where we had
Ma'am,
found
in
such that?
lecture itself, na sir told that when we toss the coin 10 times, so what will be the distribution of the any event? So we will calculate PMF like one head or two head. So it will follow some distribution, geometric distribution or uniform distribution, like that. So we have calculated PMF for that. Suppose we want to distribution, but in the same question sir asked about distribution, so we are finding CDF. So that is my doubt. Since earlier we were using PMF, okay, for discrete random variable, and
Okay,
from,
can you tell me that lecture? Which lecture was that?
I mean, any of lecture of week 1, you can. I mean, sir told na that if the probability will remain same for all uniform, suppose 1, 2, 3, 4, or so it will follow the Bernoulli distribution. Suppose we have a dice, so it will follow the uniform distribution 1 to 6 with probability 1 by 6. Okay.
There we know, right?
So that's why, ma'am, we are using PMF in that case, like probability for 1, probability for getting 2. So it is the uniform distribution 1 by 6.
There we know that this is the distribution. We know that is the uniform
No,
distribution.
ma'am, we don't know. We are calculating for
Yeah,
probability.
we are calculating, and then we
Yeah,
are.
after
But
that,
can you
we know.
calculate here for each everything? We are just given x1, x2, xn, and we are just saying they are IID x.
Yeah.
Can you find the values for each of the xi's, the value for each of the xi?
So, ma'am, that is my doubt. Means, is there any specific condition which will be written in question, or is
So
there
if
any
it will be
like where to find PM and where to find when to find
it will
CDF?
be mentioned in the question. Have you come across any questions in the
But ma'am, in that question,
activity
it is not written.
practice?
It is written that find the
But he
distribution.
has explained later, right?
Yeah.
Like if you try to find f, like small f x1 of z, you cannot find that because nothing, you have no information there. You have n samples and random variables and their IDX. So how will you find f, small f of x1 of k, something like that?
Okay. Okay, ma'am.
Yeah. Move to the next question.
Hello.
Yeah, I saw your question.
Is my voice clear now?
No, it is not very clear, but yeah, I saw your question. Probability of A complement union B complement is 14 by 16 to the power n in that lecture. I think know what you're talking about. Wait. Okay, so we had to find the probability that 3 occurs at least once. Intersection 4 occurs at least once.
Yes, ma'am.
So we can define this to be A and we can define this to be B. Correct? Now, what we're interested in, we are interested in finding value of A intersection B. So all the expressions are clear, right? So this is De Morgan's law that we use. So this is probability A complement B complement complement. Is this clear? Like this is a De Morgan's law that we're using here.
Yes, ma'am.
Right?
Yes.
Now, so in order to find probability of A intersection B, we'll have to find this. Right? And what we can write it as 1 minus probability of A complement union B complement. Correct?
Yes, ma'am.
Now we have to find this. So what is this? This is 1 minus probability of A complement plus probability of B complement minus probability of A complement intersection B complement.
Yes, ma'am.
Now what is probability of A complement? What is A? A is 3 occurs at least once. So we had a random variable to find. So x is 0, 1, 2, 3, 4. And x is 1, this is 1 by 2, this is 1 by 4. This is again 1 by 8, this is 1 by 16. And this is 1 by 16 again. Yeah. So we have to find probability of A complement. It means that A 3 occurs at least once. So we have to find the probability that 3 doesn't occur. Okay. So what is 3? This is 1 by 16, right? Probability of occurrence of 3 is 1 by 16. But we have to find A complement. So that will be 1 minus, just 1 minus 1 by 16. So that is 15 by 16. Right? But we have n number of samples. Right? We have n number of samples given, right? Hello, I'm audible?
Yes, ma'am.
Yeah.
Yes, ma'am.
So we have n number of samples given. So it will be just 15 by 16 to the power n.
Yes.
Similarly for this, and I think that was the doubt about n. This is because of your samples, number of samples.
Ma'am, that I got, but ma'am, that's the probability that C doesn't of the intersection.
So what is probability of A complement? This is going to be 15 by 16 to the power n. B complement is also going to be same, right?
Yes.
So this is 15 by 16 to the power n minus probability of A complement. It means 3 should not occur and 4 should also not occur, right?
Yes.
So what does it mean? That probability A complement intersection B complement. It means 3 should not occur and 4 should not occur. So probability that we can write x1 not equals 3 comma 4, x2 is also not equals 3 comma 4, and it can go to xn. Is this fine? So all are IID x. So we can write probability x not equals to 3 comma 4. Which are n, right?
Yes.
So if I'm saying probability x not equals to 3 by 4, 3 comma 4, it means x is taking the value either 0 or 1 or 2. So so these two are making it 2 by 16. So 1 minus 2 by 16 will give you 14 by
14 by 16.
So this will come out to be 14 by 16 to the power n. Just now substitute everything and we can solve it.
Yes.
Okay, so if nobody has any problems now, we can close the session. Is it fine? Anybody has any doubt? More doubts? Okay. Kartik, can you stop the live streaming? Kartik, can you close the session?